Agilent's M9018A PXIe chassis delivers the flexibility, compatibility, and performance necessary to assist designers and engineers through today's most difficult test system challenges. These include the integration of RF and microwave measurements requiring higher power dissipation, and the need to maintain a stable measurement environment for long-term validation or durability testing. This solution offers a complete set of chassis monitoring functions for power rail voltages, module exhaust temperatures, and fan speeds. These tools can be used to ensure repeatable and reliable test results. A rich set of IVI commands provides access to the M9018A's built-in monitoring features. We'll demonstrate these features using this example chassis data logger program built upon these IVI commands. For temperature measurements, the chassis utilizes 8 temperature sensors located on the top of the backplane in the path of the module exhaust. These sensors allow you to monitor the temperature of the air as it is exhausted from the modules. Starting the example chassis data logger, we see the collection of many parameters within the chassis. Focusing first on temperature, you'll note both tabular and graphical presentations of the data are provided. Graphically, we can see that the maximum slot temperature is approximately 30 degrees Celsius. The graphical representation using thermometers displays at a glance how temperatures vary across the chassis. If we add the demo system below the graphical temperature readout, we see the variation across the modules installed in the chassis. This variation is normal because each module dissipates a different amount of heat. Depending on the type of modules installed, you can use the temperature sensors to identify and correct hotspots during system development. You may also use the IVI commands and temperature sensors to monitor chassis temperatures during long tests. This can be done to log environmental changes which may impact the testing. In addition to temperature, you can also control and monitor the cooling fans. The M9018A has 3 large fans which are used to expel hot air. We can control the temperature inside the chassis by controlling these fans. A user-settable fan control algorithm is used to control the fans. Notice that this algorithm is controlled by the maximum RPM temperature set point. This is currently set to 50 degrees Celsius, which is the default value. Note also that the fans start ramping up in speed at approximately 25 degrees Celsius below this set point. This algorithm provides high airflow for power-intensive configurations, while also allowing reduced fan speed and noise when power consumption is low. We can show the actual impact of this fan control with our example chassis data logger program. Note, with the temperature set point of 50 degrees Celsius, the fans are running at a relatively low speed, since the temperatures in the chassis are much lower than this threshold. If, however, we change this maximum RPM temperature set point to 25 degrees Celsius, the fan will respond by increasing in speed, and that the temperature will start to drop in the chassis. After a few minutes, we can see that the maximum slot temperature has dropped 2 to 3 degrees Celsius across the chassis. The advanced chassis monitoring functions within Agilent's M9018A's PXIe chassis can help ensure success in meeting your most difficult automated test challenges.